This is going to, we're going to do a transportation problem. Alright, so we have warehouse 1 and 2 that delivers to, we have suppliers 1 and 2, okay, that delivers to warehouse 3 and 4, and warehouse 3 and 4 has to deliver to um, stores 5, 6, and 7, yeah. So the 1 and 2 here is like the, what's this, the nodes 1 and 2 are the two bakeries, 3 and 4 are the warehouses, and 5, 6, and 7 are the restaurants, okay. Now the associated costs are given here, right? So from 1 to 3 is gonna be, 30 cents, 2 to 3 is gonna be that, and so on. Alright, so because you can see here, 1 to 4 is not possible, right? 4 to 5 is not possible. So to do this, we are going to use some index. Okay, so let's say bakery I, which is from 1 and 2, and J is the index for warehouse, which will take the values 3 and 4, and the restaurant has an index K, which has values 5, 6, 7. Okay, and we define Xij to be the number of slices from bakery I to warehouse J. Yij is the number of slices of bread goes from warehouse J to restaurant K. Right, so we want to minimize the total cost. We are going to make it like this, so sum Xij, I from 1 and 2, J from 3, 4, okay, and this should be Yjk, yeah, right. Xij times Cij, okay, plus Yjk times Cjk. That's how you represent the total cost. Okay, and then now we have the demand and supply constraints. So the first one is that you have 1,000 and 1,100 cake slices from bakeries 1 and 2. So there's 1,000 coming out here and 1,100 coming out here. Okay, and also you have 300, 200 already in warehouse 3, and 5 needs 800, 6 needs 900, and 7 needs 500 slices. So we're gonna be putting it in here, right? So 1,000 and 1,100 will be coming from node 1. That's how you represent it. Okay, and then this one says that those coming out of node 3 is Xi3 plus 200. See, so Xi3 is everything that goes into the 3, and plus the current 200 that it has must be less than or equal to everything that comes out of 3, from 3 going to K, right? This is the same logic in here. Everything that goes to 4, okay, is less than or equal to everything that goes out from 4, okay? And then this one says everything that's going into 5, okay, must be 800, at least 800. Everything that goes into 6 must be 900, and then everything that goes into 7 must be at least 500. So going into 6 or 7, okay. And then obviously Xij and Yij are integers, okay, positive integers. So the first thing that we are going to do is make the problem simpler for us, right? So we put the costs in here per slice. From 1 to 3 is 30 cents, but from 1 to 4 is impossible, so we're gonna put any big number. So I'm gonna be putting 999 here. 999 is much bigger than 30.3, so this should work, okay? So I'm gonna be putting all the numbers in here, and all those that are impossible, I'm gonna be putting a big number, okay? Again, this is an ingenious way of doing this, okay? This is not the only way of doing this, but I find that this is a very ingenious way of saying that this is not possible. I'm gonna be putting a big enough number in here. And remember that we're trying to minimize the cost. So if you're trying to minimize the cost, the computer will not select this node here from 4 to 5 because the cost is big anyway. Yeah. And the computer will not select from 3 to 7 or from 1 to 4 because the cost is big. And remember that we're trying to minimize the cost. Now these are the decision variables. Okay, so the decision variables are the number of units coming from 1 to 3, and from I to J, and then from J to K. So to formulate this, we are just going to get the cost. Okay, so the cost is this, sum product. Okay, sum product of this one with this, and then this one with this. Okay, that's the cost. Now we need the demand. So we say everything that goes out of 1 must be 1100. So everything that goes out of 1, okay, so it's gonna be this equals sum. Okay, goes out of 1 there, and this is everything that goes out of 2. Okay, we say that it has to be less than or equal to 1100. Less than or equal to, okay, this one is 1000. Shoot. Okay, 1000 and 1100. Okay, I'm gonna make it smaller. Okay, now this one here says it. Everything that goes out of that comes into 3 plus the 200 that it has. Okay, so where's that? Everything that comes into 3. This one here. This is everything that comes into 3, right? Okay, so everything, I'm gonna just simply move this here. I'm gonna move this here. There. Next is that everything that comes into 3, that's gonna be this plus this, okay, plus the 200, okay, is also going to be less than or equal to, okay, less than or equal to everything that comes out of 3. Okay, so everything that comes out of 3 is here. Okay, everything that comes out of 3. Hey. No, not Daniel, no. Okay. Now here, everything that goes into 4, okay, everything that goes into node 4, this is it, okay, must be less than or equal to everything that comes out of node 4. This one here. There. Now, this one says everything that goes into 5, okay, goes into 5 is this, okay, must be greater than or equal to 800. Okay, so everything that goes into 6 is this one. Okay, everything that goes into 7 is this. Right, so they are all, let's get this 800, 900, and 500. Okay, so now we're ready to set this one up. Say data, where's the solver? Okay, so data solver. Right, okay, so here we want to minimize the cost. Cost is this one, okay, by changing the constraints here. So we have this one comes this one, okay, subject to the following constraints. Number 1 is that this has to be less than or equal to this, okay. Second is that this one here has to be less than or equal to this. And the third is that this one here has to be greater than or equal to this. Okay, and xij and yij are integers. So, okay, so we say this one, okay, is an integer. Okay, and this one is also integer. Okay, and then you hit solve, and that should do it. Okay, found the solution, and where's the solution? There. Okay. Yes. That. There's 10,000 there. Oh, I see. This should be greater than or equal to. Okay. Alright, so I have to modify the constraint. So the one for F36, we have to change this. Okay, it has to be greater than or equal to. Okay. Solve it again. Oops, tap it here. Okay, we're going to solve it again. Alright, I hit the solve. Okay, solving. Okay, so now this is the solution. Be quiet. So 900 from 1 should go to 3. Okay, the 600 from 2 should go to 3, and then 500 from 2 should go to 4, and so on. Right? So this is the solution.